Good day, everyone. We are now taking up the topic about the basic ideas of sets. So, to start, our objectives here are the students are required to well-define sets, subsets, universal sets, null sets, and cardinality of sets. Number two, they are required to illustrate the union and intersection of sets and the difference of two sets as well. To start with, sets is one of the most fundamental concepts in mathematics. The set theory, which was developed in 19th century, is now a common part of mathematics and can be used as a foundation from which nearly all the mathematics concepts can be derived. Numbers are part of human life. The moment you were born, your parents probably noted the time, your length, your width, and most especially your toes. Numbers accompany you throughout life. You use numbers to measure your age, keep track of your grades and allowances, and measure your wealth. So you're required, or you're given time, by the way, to perform the activity entitled Identify Me. Question: what comes in your mind when you hear about the following words? Letter A, the library. B, K-pop. Letter C, social media. So at least you're given ample time to perform that activity. Let's continue. What is a set? As a concept, we should know the characteristics of sets. So usually the description we encounter in some books about the characteristics of sets, these are the collections or group of objects. And it is well defined, which means that it is possible to determine whether an object belongs to a given set or not. So, give you an example of what is really a well-defined set and a not well-defined set. So, for well-defined set, we have a set of Philippine president. Second, set of dishes. Third, we have a set of counting numbers. Fourth, a set of odd numbers. As you notice, it is well defined because we can exactly roster out the sets of those examples. Like enumerating the Philippine presidents, we can. A set of dishes, we can also enumerate that instantly. Counting numbers, of course, as well as odd numbers. Now, for an example of a not well-defined set, these are a set of all numbers. So, if you try to analyze a set of all numbers, it is macroscopically broad idea. You cannot even identify exactly what are the large number. And notice that numbers are undefined in a sense. we are talking about large numbers, what should be your reference in identifying the large numbers? So that should be identified accordingly. Now, another example, a set of good writers. Now, what should be our criterion or criteria in determining the good writers? Then the third example, we have set of nice people in your class. Now, what should be your criteria of identifying nice individual or people in your class? So these are the not well-defined set. So to continue, how to write a name set. A set is represented by a capital letter. So take note with that. Now, set is composed of elements, and the elements are usually represented by small letters, numbers, words, or representations of the members of the given set. And we usually use braces as our symbol of grouping those roster of sets or enclosing the elements. And in order to separate elements, we use commas. So we have an illustrated example here. The capital letter A serves as a set, and it is equal to the quantity, meaning the group of, which we are using braces, small letters A, E, I, O, U, which we consider as an elements of the set. And we usually use comma to separate them for us to identify exactly the number of sets in. Okay. Another example, we have set K. It's composed of the elements of red, blue, yellow. It's about colors. Set R. It is composed of numbers 1, 2, 3, 4, 5. And there is 3 dots provided. So we will discuss that later. Another example, we have set P. It is composed of plus, minus, times, and divide. Symbols of operation. We'll continue. The 3 ways to describe set. We have roster, notation, and listing method. Or listing method. Roster notation or listing method, so it's a way of listing each elements of set inside a symbol of braces. So each distinct element is listed once, and the order of listing the elements does not matter. So listing elements means unique elements or has no duplicate elements. Okay, so you should take note of that. Examples, we have set A, roster of numbers 1 up to 3, or 1 up to 4. 1, 2, 3, 4. Letter B, we have listing of all the letters within a word Philippines. So you'll notice that we are mentioning only the letters once. Like, so we have P, H, I once lang, and P once lang. Then L, N, E, S. For letter C, it's a set of numbers increased by 5. So we have 5, 10, 15, but there is 3 dots provided. So that is what we call ellipses. It means we are continuing to the greater value than 15 by 5. Letter D, we have set of cell phones, model, or like Oppo, Vivo, and Samsung. Now, 3 ways to describe sets. Again, number 2 is verbal description method. So it is a method of describing a set in words. Example, a set A is a set of counting numbers less than 5. So what you're going to put in your roster set is are the numbers less than 5. More than that is not included. Second example, set B is a set of letters in the words Philippines. So this already illustrated in the roster form. Number 3, set C is a set of positive multiples of 5, or these are numbers increased by 5. Positive multiples of 5. Number 4, set D is a set of mobile phones. Okay. The third one is set builder notation or rule method. These are a method that lists the rules that determine whether an object is an element of the set rather than the actual elements. For example, again in letter A, so we can represent, we're using roster of numbers less than 5. So we can translate it through set builder notation in the form of open parenthesis, open braces, or open brace, x such that x is counting numbers less than 5. So again, it can be read as the set of all x such that x is a counting number less than 5. So the vertical bar after the first x is translated to as such as, or such that, rather. Letter B, number 2 rather. B is represented by set builder notation in the form of x such that x is letter in the word Philippines. Number 3, letter C. So set builder notation, we have x such that x is a positive multiples or multiple of 5. Number 4, letter D, or set D rather, x such that x is a mobile phone. So those are examples of set builder notation. So let's continue. So in activity 2, again, you'll be given time to perform this. Letter A, you're required to copy and fill out or fill in the table below with a correct translation of the given description of sets. Letter B, write the answer in your mathematics notebook or a paper will do. So the first one is done for you, meaning it will serve as your reference or example in performing this task. Okay, we will continue to the next. This is also a part of activity. Set W is a set whose elements is counting numbers between 2 to 5. So you have to perform that. Okay, let's continue to the kinds of sets. First is finite or finite sets. These are sets with a defined number of elements. So a defined number of elements means that it is countable, or we can count the number of elements. For example, set A. We have an elements of small letters A, B, C, D, E. Number 2, set L is equal to set of numbers 0, 1, 2, 3. So these are considered as finite sets. Second, we have an infinite sets. These are the sets with an infinite number of elements. An infinite number of elements means that the number of elements cannot be counted. Then, as what I've told you earlier, that if you can see 3 dots after an element or set of elements, that means to say that it's being added to indicate that there are more elements of the same kind that follows after the last identified element in the set. So it is very clear. So example for that, set B, which is equal to 2, 4, 6, then there are 3 dots after. We have 3 dots after, then that implicates the idea of elements, meaning added numbers to indicate that there are more elements of the same kind that follows after the last identified element in the set. Example number 2, which is considered also as an infinite set, set H is equal to x such that x is greater than 0. So it is infinite in the sense that there are many or infinite numbers which is greater than 0. Okay, the third kind of sets is joint sets. These are the sets having at least one common element. So we are now on the point of comparing two sets. Just like we are required to compare set D and set E, where set D is composed of 1, 3, 5, 7, and 9. While set E is composed of elements of 2, 4, 6, 8, and 9. So these two sets are considered as joint sets because they have common element of number 9. Another example, we have set C compared to set D. Is also an example of, by the way, we are talking about another set of elements. We call this as disjoint sets. So disjoint sets are sets having no common element. So, for example, letter C, we can set C, we can consider them as a disjoint compared to set D because set C has an element of 2, 4, 6, 8, while the set D 1, 3, 5, 7. So it's very clear that there's no common number within them. So they are disjoint set. By the first example, we are also comparing the set W and set Y, where set W is composed of an elements A, B, C, D, while in set Y we have an elements of 1, 2, 3, 4. So no common element between two sets. Okay, we'll continue. We are now on the notations and symbols. So if you see a bold capital letter E, that means to say that is considered as the element, which means that it belongs to the given set or a member of a set. For example, if set A is composed of 5, 10, 15, 20, then 5 is an element of A, 10, 15, and 20 as well. So that is how we can portray the idea of the symbol of the element E. Now, how to read that? Okay, you have there 5, an example. 5 is an element of A. Another symbol, bold letter E slash. So, meaning to say that it's not an element of. For example, if A is composed of 5, 10, 15, 20, then not an element. For example, 7 is not an element of A. It's not included in the set, in the roster. You have there also an example of letter A now. A is not an element of set A. Another symbol, N of the quantity of capital letter A. So which means that we are talking about cardinality of set A. So the number of elements in the set. Meaning whatever is a set inside, as long as you can count them. So we are talking about cardinality of the set given. Like for example, set A, composed of small letters A, E, I, O, U. So to identify its cardinality, how many elements we have? So we have 5 elements. So the meaning, the cardinality of such set is equal to 5. Next, the symbol of equivalent sets. These are two sets that contain the same number of elements. For example, set A is composed of 1, 2, 3, 4, while set B we have M, A, T, H. So letters for letter B. So we can consider them as an equivalent sets, not in the identification of each element, but to the cardinality of each element. Each set is composed of 4 elements. Therefore, these 2 elements are equivalent sets. So next, equal sets. So take note, equivalent set is different from equal sets. Equal sets are 2 sets that contain the same elements. So we are now particularly on the identification or enumeration of an element. In whatever arrangement, will do as long as all elements mentioned for the first set is the same as the second set. Like for example, set C, we have A, E, I, O, U, while in set D we have E, O, I, U, A. So, set C and set D contains the same elements. So, they are equal sets. Next, the notations and symbols. So, continue. Bold capital letter C, then there is a dash below. So that means it is a symbol of a subset, where every element in A is also an element in B. Like for example, in number 1, we are comparing a set of 9, 14, 28. So, 9, 14, 28 is also a subset of the same set. 9, 14, 28. So, if we consider the first set as our set A, then second set B. So, therefore, set A is a subset of set B. So, number 1 example implicates the idea that whatever is the given set or elements in the given set, copying the same. So, we can consider the same as the same set of elements as subset of the given. While in number 2 examples, in set A, we have 2, 4, 6, 8 ellipses. In set B, we have 1, 2, 3, 4, 5 ellipses. So, in this case, we can consider that set A is a subset of B. The reason that A are a set of numbers, set of even numbers, increasing even numbers. And set B is a set of counting numbers. So, it's very clear that A is a subset of B because all those even numbers mentioned is also a part of or is also in the counting numbers, a set of counting numbers. So, A is a subset of B. Another symbol, we have C, bar in below, then slash. That means to say that this we are talking about a subset. These are a set. That means to say that set A does not belong to set B. Not a subset, rather. So, example, A is equal to 2, 4, 6, 8, while B is 1, 3, 5, 7. So, there's no common between them, and we are not considering all numbers in this case. So, we particularly mentioned those numbers only. 2, 4, 6, 8 compared to 1, 3, 5, 7. So, there's no common between them. So, A is not a subset of B. So, if you can only see a capital letter, bold capital letter of C, that means to say it is what we call a proper subset. There is at least one element in B not included in A. So, we can consider it as proper subset. It's like in set A, we have an elements of A, B, C, while in set B, small letters of A, B, C, D. Then, set A is within, or is mentioned also in set B. So we can consider set A as a proper subset to B. So we can state it in this way. Each element in A is also an element in B. Or there is at least one element in B not contained in A. And that element is D. So that is an idea of proper subset. Bold letter C slash. So that means not a proper subset. Not a proper subset are the elements in C is not equal to the elements in D. So for example, C contains an element of 1, 2, 3, and D contains 1, 2, 3. So all the elements in D are also elements in C. Therefore, C is not a proper subset in D. Symbol, okay. Another symbol of it's a kind of capital letter O slash, or an open close parenthesis, open close braces. It means an empty or a null set. These are a set with no element. Example, M is equal to open and close braces, so it is an example of an empty or null set. Capital letter U, so it is known as a universal set. The set of all possible elements of any set. So it's represented by capital letter U. Now, how to solve for subsets? Given M is equal to an X and Y, or composed of elements X and Y. So write the complete list of subsets. So note that M has two elements in a symbol. But talking about cardinality of M, it has two elements. Okay. Always consider